Hi everybody, welcome back. In our last set of videos we were looking at categorical variables, but we were looking at categorical independent variables. In this video we're going to be looking at categorical dependent variables, so the y or outcome variables, and thinking about how we can model them, which is going to end up being our first departure from normal ordinary least squares models. So this linear probability model is an OLS type model, but we're going to see that there are several problems with that, and ultimately defer to a logit model. Also, we'll talk about a very similar probit model, binary probit. So these are the types of models we're going to be looking at, and again, we're modeling this y variable as a 1 or a 0. So a yes or a no, or part of a program or not, self-employed or not, did the person graduate or not, participation in the labor force. So these are the types of questions that we'll be able to answer. So if we want to model, for example, what student characteristics or maybe university or class characteristics will contribute toward a person graduating from college, we'd have a model where we have a graduate, if somebody graduates, and then we model that with some sequence of control variables and epsilon error term. But if somebody graduates, they get a 1. If they don't, they get a 0. So this is the type of problem we're going to be estimating. Previously, we always used continuous variables for the y. So income or sales or the price of a house, for example. So here we have categorical dependent variables, and we're going to start in this video by looking at the linear probability model. So, linear probability model, this is a model linear in its coefficients used to explain a categorical outcome. Again, that's a model linear in its coefficients used to explain a categorical outcome. Okay, and as I sort of mentioned before, we are going to be estimating that using ordinary least squares, and ultimately we have a 1 or a 0 as the outcome, but we're going to think of that as modeling the effects as changes in the probability of an outcome occurring, because probabilities range between 0 and 1. So what we're doing is modeling effects as changes in the probability of an outcome occurring. Okay, and so let's write this out as a short little model here. So let's use this di as sort of an indicator variable that's going to be either a 1 or a 0 as a function of our intercept as before. And we're going to add 2 independent variables in here, beta 1 x1 plus beta 2 x2, and our random error term. So we're going to be modeling the probability, and what we can then do with our independent variables, with the independent variables, we can do the following. So one is that we can predict whether or not an outcome will be 1. Predict whether an outcome will be 1 or 0. So again, for example, we could predict the graduation probability of a student based on some observable characteristics, x variables. Or we could look at the causal effect of changing an independent variable for example, x1, or maybe if we wanted a real example, let's say class size. If we're thinking about, say, graduation of a student. So look at the causal effect of changing an independent variable on the probability of the outcome being 1. And so again, what we could say is, for example, what's the effect of class size on the probability that a person graduates? Or if maybe there's some special policy or new procedure for freshmen in place, you could say, what's the effect of, so for example, at our university last year, I think maybe this year too, they provided free ski passes to the freshmen. And so you could model, for example, what's the causal effect of providing ski passes on, say, the probability that a freshman continues on for their second year. It's to get fully the causal effect, we're going to have some of the other issues with unobservable selection bias as before. Causal effects are much harder to do, but we could certainly look at, we could use this type of model to look at the correlation between a program like that and the probability of retention or graduation. Okay, so moving along, I just want to show a quick example of what this is going to look like in a data set. And so let's say, as another example, we want to model whether or not somebody is self-employed. And let's suppose that this is going to be a function of whether or not that person, so self-employment of individual I, so individual level data set, and see if, say, student loans have an impact on self-employment. And we'd add a bunch of other control variables in here and epsilon, their term. So what is the data going to look like for this? If you had, say, in Excel or in Python or somewhere, you'd have individual I over here, 1, 2, 3, and say the first person, they are self-employed, and they have, say, $20,000 of student loans. Say this is measured in thousands. Let's just put 20,000. And the next person is not self-employed, so they have a 0. Let's say they have 50,000. Say 0 again, and say they also have 50,000. But ultimately, we would fill in this well, we'd probably start with a data set that already exists, but our dependent variable y is going to have this sort of characteristic. And so now we run our model, and then let's suppose that beta 1 is equal to negative 0.02. And then what we could then do is, if, you know, depending on how our model is set up, we're gonna make a couple hand waves. But for example, let's say for every $1,000 and for every $1,000 increase in student loans is associated with a 0.02 or 2% decrease in the probability of self-employment. And so if that is what our beta hat, so our estimate of beta hat, if beta 1 hat is equal to negative 2%, then suppose every $1,000 increase in student loans is associated with a 2% decreased probability of being self-employed. Okay, so that's a little bit of a setup for the linear probability model. I'm actually going to go ahead and just stop it right there. I think we have enough for one video. But in the next video, what we're going to do is pick up and look at some of the problems with the linear probability model, so that ultimately we're going to decide to use something like a logit or a probit model. Okay, so thanks for watching, and I'll see you in the next video.